Okay, today we are going to learn about current forces on a current conductor. So before we learn about forces on a current conductor, so you have already know that a straight wire which carry a current will have a magnetic field which we can determine by the right hand grid rules. So for your right hand grid rules, the thumb will show the direction of your currents and your four fingers will show the direction of the magnetic field. So which is, this is your current, so this one will show you the magnetic field, which is rotated anti-clockwise of your current carrying conductor. Okay, so means that every straight wire that have current pass through it will produce a magnetic field. So let's say a permanent magnetic field is placed in between your current carrying conductor is placed. So this current carrying conductor straight wire will put between these two magnetic field. So the magnetic field produced here will have direction that pointed from north to south. So we know that the magnetic field produced will be pointed through north to south. Okay, so this is your magnetic field for a permanent magnet. So now there is a current carrying conductor that the current is passing through from the positive pole to the negative pole, or from the high potential to the lower potential. So this current carrying conductor at the same time will also produce a magnetic field. So if there is a outwards current, so this show that there is an outwards current that carrying outwards currents. So means this symbol means the current is flowing up. Okay, this symbol means the current is flowing out. For this one, the current is flowing in. Okay, so let's say it's flowing out. So we know that using right hand rules, so we can determine the direction of the magnetic field for this conductor. Okay, so it's flowing out, so the thumb will point to the direction of your current, which is outwards from the paper, and then this direction will show you the direction of your magnetic field, which is rotated anti-clockwise. Okay, so it will be rotated anti-clockwise. So if these two fields are put together, so it's just like this figure, so they will produce a resultant magnetic field based on the direction of the magnetic field of both magnetic field. So let's look at above the conductor. So above the conductor, the magnetic field produced by the conductor is pointing to the left. While if you put it at here, so it means that this upwards magnetic fields from the conductor will produce a weaker magnetic field, because there is a permanent magnetic field in this direction and your magnetic field produced by a current conductor is in this direction. So both magnetic field will causes a weaker magnetic field. Means at the upper here will have a weak magnetic field, while for the lower part here, both direction of the magnetic field are pointed at the same direction. If you look carefully, this one is to the right and this one is to the right. So both are pointed to the same direction. Thus, they will produce a stronger magnetic field at here. So because of this difference in magnetic field, so they will produce different magnetic field strength. Means this one will have a weak magnetic field strength and this will have a stronger magnetic field strength. So the combination of these two magnetic field we call it as catapult field. Okay, both these magnetic field added up we call it as catapult field. So how do you draw your catapult fields? So this one, bottom one, we have a stronger. So whenever we draw stronger field means it will have a lot more lines on the bottom. So more lines will be on the bottom. Okay. Because here we have a stronger field. So for a weaker field, so they will have less magnetic field lines. So we know that at the bottom part, there is a stronger field. And this one has a weaker field. So when a stronger field and weaker field, they will produce a resultant field which is pointed in this direction. So because of magnetic fields, the difference in magnetic field strength, so they will produce a force acting on this conductor, which is pointed from the stronger to the weaker field, which is upwards force. So the forces that acted on this current carrying conductor will push your conductor to the upward direction. Okay, so this force is actually produced due to the difference of your resultant magnetic field strength. So this magnetic field strength will produce a force which we call it as magnetic force and push the conductor to upwards. So it will move the conductor. So let's say now you have another field which is still pointed from north to south. Okay, then this one is the current that flowing into the page. So when a current flowing into the page, so the thumb will point it into the page and will produce a clockwise direction magnetic field. So you have a magnetic field which is rotated in clockwise direction. So if you look carefully for these two to be combined together and form the catapult field, you'll find that at the upper parts here, both this magnetic field are pointed to the right, means they will have a stronger field at this part. And then they will have a weaker field at this part. So when you have a stronger field at this part, so we will form a catapult field in this shape. So you have more lines on a stronger part. So we know that because of the difference in a magnetic field strength, so it will produce a force which is pointed from the stronger part to the weaker part, because the strong one will pull to the direction of the weaker part. So your current carrying conductor will be pushed downwards due to the difference in the magnetic field strength. So this is the force produced, this is the direction of the force produced due to the current carrying conductor on a permanent magnet. Okay, so this force can be easily determined by using left-hand rules or Fleming left-hand rules. So before I introduce the Fleming left-hand rules, let me explain to you what these fingers represent for each quantities. So for your thumbs, it will represent the direction of your force due to the catapult field, while this one will represent your directions of your magnetic field, which is denoted as B. Okay, your magnetic field here, we always denote it as B. Okay, direction of your magnetic field. So this show the direction of your force produced, and this show your directions of the magnetic field, and this will show your direction of the current carrying conductor. So if you look at this direction, So you know that, okay, let's say you have these two. Okay, you have B pointed from north to south. So your B will be in this direction. This considered as your B. While this is your current carrying conductor, which is pointed outwards. So this have to point outwards. Okay? So it means that this pointed outward and this pointed to the right. So it will produce a force upwards. See? It will produce a force upwards. So these three fingers have to be perpendicular to each other. So these Fleming left-hand rules will help you to determine direction of the force that produced by your current carrying conductor.